The bird at your feeder right now is not seeing what you think it is seeing. It is not seeing the same yard you see. It is not seeing the same colors. It is not even seeing you the way you appear to yourself in a mirror. The bird looking at you from the branch 6 feet away is processing a version of the world that contains an entire dimension of visual information that your brain has never accessed, cannot access, and has no framework to imagine. And the way you appear inside that visual system is something that would be unrecognizable to you if you could see it. Today we are going into exactly what that visual system is. The 4 color receptors birds have that you do not. The ultraviolet layer of the world that is invisible to you and in full color to them. What your feeder looks like through their eyes. What your skin looks like. What your clothes look like. And the one thing about how birds see each other that completely changes the way you understand every bird you have ever watched. Stay until the end, because the last section explains something about the birds in your yard that you have been observing your entire life without knowing what you were actually looking at. You have 3 types of color-sensitive cells in your eye. Cones, each tuned to a specific range of wavelengths. One peaks in the red range, one in the green, one in the blue. Every color you have ever seen in your entire life, every sunset, every painting, every face, is constructed by your brain from the combined signals of those 3 cone types. The entire visible world as you experience it is a 3-channel output. Trichromacy. 3 colors mixed into everything. The bird at your feeder has 4, not 3. 4 cone types, with a 4th receptor tuned to wavelengths in the ultraviolet range, between 300 and 400 nanometers, well below the threshold of human visual detection. Research by Gabrielle Nevitt at the University of California, Davis, and foundational work by Andrew Bennett and Innes Cuthill at the University of Bristol confirmed across multiple bird species that avian color vision is genuinely tetrachromatic. 4 independent color channels producing a color space that is mathematically larger than anything a human eye can generate. What does that mean in practice? Think of it this way. If human color vision is 3-dimensional, every color you can see plotted in a 3-dimensional space, bird color vision is 4-dimensional. There is an entire axis of color information that birds navigate that has no equivalent in your visual experience. No human has ever seen a UV color. Not a dim version of it. Not a pale version. The color simply does not exist in human perception. It has no name because we have never needed one. Birds are moving through a world that contains colors you cannot imagine, because imagining a color requires having the receptor to process it. The UV sensitivity is not a minor addition. Research by Tim Goldsmith at Yale University quantified the contribution of the UV receptor across multiple songbird species and found that UV reflectance patterns on bird plumage were present in every species tested, often in patterns invisible to human eyes that were clearly visible and likely significant to other birds of the same species. The male house finch at your feeder, whose red coloring you find striking, is visible to a female house finch in a completely different way. The UV patterns on his crown and breast that you cannot detect are part of what she is evaluating. The bird you are watching is not the bird she is watching. You are both looking at the same animal and seeing different things. Here is what your bird feeder looks like through tetrachromatic eyes. The sunflower seeds in the tray are not just black and white. Many seeds have UV reflective coatings, oils, wax compounds on the seed surface, that reflect strongly in the ultraviolet. A sunflower seed to a chickadee is not a dark oval. It is a complex object with UV highlights that indicate freshness, oil content, and nutritional value. Research by Hannah Rowland at the University of Cambridge demonstrated that birds use UV reflectance from food items to assess quality before handling, reducing the handling time of lower quality food items in controlled experiments. The bird is not just seeing food at your feeder. It is reading nutritional data from light wavelengths you cannot perceive. The feeder itself may be invisible to them in ways you would not expect, and visible in ways you would not predict. Plastic feeders often reflect differently in the UV range than they appear to human eyes. The red plastic of a hummingbird feeder that looks uniformly red to you may have UV reflectance patterns that make it visually complex to a hummingbird. The clear plastic walls of a window feeder may be nearly transparent in the UV range, meaning the feeder appears to have no walls from certain angles. Research by Daniel Clem at Muhlenberg College on bird window collisions documented that standard window glass is UV transparent. Birds cannot see it as a barrier because it does not reflect in the UV range the way solid objects do. The window that looks obviously solid to you is visually absent to a bird. That is why they fly into it. Now here is the part that most people never consider. What do you look like? Human skin reflects ultraviolet light. Not uniformly. Not in ways that look like skin to us. The UV reflectance pattern of a human face is a map of blood vessels, melanin distribution, and collagen density that is completely invisible to human eyes and potentially visible in some form to birds with UV receptors. Research by Jörg Endler at Deakin University on UV signaling across vertebrates documented that primate skin, including human skin, has measurable UV reflectance properties that differ between individuals, age groups, and health states. Whether birds process this information consciously, or whether it simply becomes part of their overall visual impression of a specific individual, is not yet fully established. What is established is that what you present visually to a bird is not what you present to another human. Your clothes are stranger still. Most laundry detergents contain optical brighteners, compounds specifically designed to absorb UV light and re-emit it as visible blue-white light, making fabrics appear brighter to human eyes. To a bird, those compounds make recently washed clothing glow intensely in the UV range. A freshly washed white shirt is not white to a bird. It is a UV beacon. Research by Matthew Symes at the Percy Fitzpatrick Institute in South Africa examined optical brightener fluorescence in the context of bird camouflage studies and found that fabrics washed with standard detergents fluoresced strongly in the ultraviolet, altering their appearance from what the wearer intended. The person who wears neutral-colored clothing to watch birds at their feeder, thinking they are being inconspicuous, may be wearing the UV equivalent of a neon sign if those clothes have been recently washed. The implications for the trust research we covered in a previous video are significant. The bird at your feeder is not just evaluating your movement patterns and your predictability. It is evaluating a visual signature that includes UV information you are not aware you are presenting. The specific UV reflectance pattern of your face and clothing may be part of how individual birds identify you specifically, as distinct from other humans who visit the same yard. Your individual recognition by the birds at your feeder may partly be based on visual information you cannot see and have no way to control. Here is the part that changes everything about how you watch birds in your yard. The bird you are watching is not showing you what it looks like to other birds. The northern cardinal, whose red you find so striking, is reflecting UV patterns on its crest and wing feathers that are invisible to you and potentially crucial to other cardinals evaluating its fitness. The American goldfinch, whose yellow seems uniform to your eye, has UV patterns on its plumage that create a completely different image to a female goldfinch assessing a potential mate. The brown-headed cowbird, whose brown head looks plain to you, may be visually complex to other cowbirds in ways that involve UV patterns on every feather. Research by Staffan Andersson at the University of Gothenburg, who has spent decades studying UV signals in bird plumage, demonstrated that in many species, the UV component of plumage coloration is the primary signal used in mate selection, not the component visible to human eyes. The colors you can see are often secondary. The colors you cannot see are often the ones that matter most to the birds themselves. This means that every bird you have ever described as dull or plain may have been visually spectacular to other members of its species. The birds that birders refer to as LBJs, little brown jobs, the sparrows and wrens and finches that seem featureless to human eyes, may be as visually complex to each other as a bird of paradise is to us. We have been rating bird beauty using the wrong instrument for our entire history of watching them. The chickadee that turns to face you with both eyes at your feeder is doing something we covered before, using its most precise binocular vision to assess you at close range. But what it is seeing in that assessment is not a reflection of what you see in your bathroom mirror in the morning. It is seeing a UV map of your face, the collagen pattern of your skin, the fluorescence level of your shirt, the specific combination of reflected wavelengths that makes you visually distinct from every other human who has ever stood at that feeder. It knows what you look like in a dimension you cannot access. And it has been filing that information every single time you appear. Tell me in the comments, have you ever had a bird react very differently to you on a day when you were wearing something different or had changed your appearance in some way? That reaction may have had a UV component you were not aware of. I read every single one. Subscribe for new videos every week on the birds in your yard, what they are actually doing, and the science behind every interaction you have ever had at your feeder. There is one more layer to this that almost no one discusses, and it connects directly to what you see when you watch two birds interact at your feeder. Birds do not just see UV light passively. Many species have UV reflective patches on their plumage that function as signals specifically because they are invisible to predators with trichromatic vision. A Eurasian kestrel hunting from above sees the world in 3 color channels. The vole it is hunting has UV reflective urine trails that the kestrel uses to locate hunting grounds. But the same UV signals that betray the vole's location are invisible to the vole because it cannot see UV. The signal is encrypted by wavelength. Only the animal with the right receptor can read it. Birds exploit this in the opposite direction. The blue tit has a UV reflective crown patch that is invisible to most mammalian predators looking up through leaves toward a backlit sky. To another blue tit, that crown patch is a status signal, a brightness indicator, a health marker. Research by Anders Muller at the University of Paris documented that the UV brightness of blue tit crown patches predicted both male competitive success and female mate preference more reliably than any visible coloration measurement. The signal that matters most is the one the predator cannot see. Your yard is full of these encrypted conversations. The birds at your feeder are exchanging UV status signals continuously in a channel that is completely closed to you. The dominant bird at the feeder is not necessarily the most colorful one to your eye. It may be the one with the most UV bright plumage that you perceive as identical to the others around it. The subtle social negotiations happening at your feeder tray every morning are partly happening in a visual frequency you have no access to. The next time you watch two birds interact at your feeder, one displacing the other, one deferring to another, the social information that drove that interaction included visual data you could not read. You saw the behavior. The birds saw the conversation that caused it. Your feeder is not just a feeding station visible to human eyes. It is a UV signaling arena, a status display space, a visual communication channel operating in a spectrum that has been there every morning you have ever watched birds, and that you have never once been able to see. There is a practical implication to all of this that connects directly to how you set up your yard and how you behave in it. If optical brighteners in laundry detergent make your clothing glow in the UV range, then the feeders, houses, and decorative objects you place in your yard may also have UV properties you are unaware of. Freshly painted surfaces often contain titanium dioxide, a compound with strong UV reflectance. A newly painted white fence may be significantly more UV bright than an older weathered one. The position of that fence relative to your feeder may affect how birds at the feeder perceive the background against which they are trying to spot other birds, predators, and each other. Conversely, research on bird window strikes consistently shows that UV reflective films applied to window glass make the glass visible to birds in the UV channel and dramatically reduce collision rates. The glass that is invisible to birds because it transmits UV without reflecting it becomes visible when it reflects UV back toward approaching birds. The single most effective intervention for preventing window strikes costs less than any other solution and works entirely in a visual spectrum you cannot perceive. The world your birds live in is not the world you live in. The yard you have built for them is filtered through your trichromatic perception of what looks right, what looks natural, what looks like food and shelter and safety. The birds evaluate that same yard through 4 channels of color information, one of which you have never accessed and cannot simulate. They are making decisions based on information you did not know you were providing, and they have been doing it every single morning, at the feeder you filled, in the yard you built, in the spectrum of light you have never seen. The bird at your feeder right now is seeing you in 4 dimensions. You are seeing it in 3. It has been seeing you this way since the first morning you stepped outside. The visual file it has built on you includes information you did not know you were giving it. And somewhere in that 4-dimensional image of you, in the UV map of your face and the fluorescence pattern of your clothes, is part of the reason it knows you specifically, stays when others leave, and keeps coming back to the yard you filled without knowing what you actually looked like to the animal watching you fill it.